Okay, still staying in 8-6. Day 2, practicing shells, and we're going to throw back in the washer formula. So you can keep them both going so you don't forget about it. So just one example today done both ways. So for this one, we're going to rotate around the y-axis. The region in quadrant 1 that's above the graph y equals 1 over x, which you might want to hit it right away, bring it up as x to the negative 1 power. That is bounded by the horizontal line y equals 4 and the vertical line x equals 3. So we got 3 equations working here. So graphing y equals 1 divided by x. And we want the part in quadrant 1, so it came down and did this little thing. So it was had the y-axis as a vertical asymptote and the x-axis as a horizontal asymptote. So it wanted the region above this graph, above it, bounded by y equals 4. I call that 4. And then the vertical line x equals 3. We're talking about this region right in here, enclosed by all 3 of them. Okay, we're going to do this with shells first. So this one's going to be shells. To do a shell, I draw my rectangle parallel to the axis I'm rotating around. I'm going around the y, so I want my rectangles to be tall. Okay, well, as soon as I draw that, I see my width is a dx. So I want all x values in my equation. So I need the boundaries. I want the x value here. This one, I already know the x value is 3. So I've just got to find this intersection here. And what I know about that point is that the y value is 4. So if I go to the equation, I know that the y value is 4. Cross products, x equals 1/4. Okay, so I got my boundaries. Ready for the volume. It's the integral from 1/4 to 3. The shell formula is 2 pi RHW. Okay, the 2 pi I got. Radius, remember, because it's going around like this, the radius is measured from the axis, from the center of the axis, out to the rectangle. That's a horizontal distance, positive x. The height, top minus bottom, in terms of x's. So my top has a height of 4 minus the bottom in terms of x is the function, so that's x to the negative 1. So there's my height. And then my width is dx. Okay, so just like yesterday, I'm going to pull the 2 pi out in front, distribute that x in. That'll give me 4x minus, that's going to give me 1. The x's are going to cancel out. So 2 pi, power rule here, 4x squared divided by 2 minus x from 1/4 to 3. 2 pi. That'll be 2x squared minus x. And we want to start at 3. 94.25. And then putting in a quarter, a negative 0.79. 94.25 plus 0.79, 95.04. Okay, now we're going to do the same one, but now I want to do it with either cylinders or washers, whatever is appropriate. So I want to draw the rectangle perpendicular to the axis I'm going around. So I'm going to start with a new graph. Make it a little bit smaller so I can fit it on my paper here. Oops. There's my y equals 4. X equals 3. I still want to rotate around the y-axis, so I need to turn my rectangle and draw perpendicular to the axis. So because I've got the gap here from my end of my rectangle to my axis, I know this is going to be a washer. So we want the washer formula. So the washer formula, remember, was pi times r1 squared minus r2 squared times by height. Okay, right away I like to know what letters I need. This little distance here tells me dy, because it's a change in y, so I know I want all y's. So now my intersections, here and here, I want the y values. Well, this one I have, the y value is 4. This one I've got to find, but I know the x value here is 3. So if I go y equals 1 over x, and I know x is a 3, y is going to equal 1/3. So my volume will be the integral from 1/3 to 4. My washer formula is pi times my r1 is the all the way to the top, or excuse me, to the right side. So it's the right edge squared minus the left edge squared. So the right are all going out to 3. So my r1 is always a distance of 3. My r2 is the function 1 over, or actually x to the negative 1, but I don't want to see x's, I want it in terms of y's. So I want to rewrite this. So if I take it, y equals x to the negative 1, and I solve this for x, I'm going to raise both sides to the negative 1 power. That becomes x to the first when I multiply. I get y to the negative 1. So now I've got r1 is 3 and r2 is y to the negative 1. So putting in the formula, I've got to square each of those and subtract. And my height is the dy. Okay, simplify before I integrate. Pull the pi out in front. 9 minus, multiplying here, I'll get y to the negative 2. And now integrate. 9y minus, add 1 here, I get negative 1. Divide by negative 1 is going to make this a plus. 1/3 to 4. Okay. Pi 9x plus x raised to the negative 1. Start at 4. 113.88. I'll go to 1/3. 18.85. See if I made any mistakes. 113.88 minus 18.85. 95.03. So just in my rounding, I'm off in that hundredths place, but essentially the same thing. Okay, so just trying to throw it all together today. Tomorrow's our last day, and we're going to do something new. We're going to go rotate around that different axis, which adds a little dimension to the radius. But your assignment then on this section, why do I keep losing this? Where are you? Ah, dang it. Oh, here it is. Page 401, 9 through 12, but I want 9 and 10 done two ways. 9 and 10, two ways. One way with shells, the other way, I think they're both going to be washers. I don't think there's a cylinder in here, but there might be. So shells and another.